Kia ora. Let's look at the last example. The molecular formula we worked out was C5H10O, and we realized there was a hydroxyl group and there was a carbon-carbon double bond. So if we look at the possible isomers, here are some of them. You could draw more of them. So the first thing we do is we look at the NMR and look at the carbon environments. 5 peaks, so 5 carbon environments, but unfortunately all of these have got 5 carbon environments. Every single carbon has got 4 different groups on it. So the next thing we can do is, what can we, with an alkene, discard some of them? And we can discard the first one because we can clearly see here this peak is between 100 and 120. That means it must be a terminal alkene, a CH2, which this one doesn't have. In this one, we can discard for exactly the same reason. We don't have a carbon of a double bond with 2 hydrogens on for that peak, so it's not that one either. We can discard this one as well because the NMR clearly shows, it's here around about 10 parts per million, a methyl group. And the mass spec over here, a tiny little peak at 71, shows a loss of a methyl group. So we must have a CH3 group. Now, that is over here in the 4th structure, as well as the 5th structure, as well as the first, but we have cancelled out the first one. So we've can see we can cancel out this one because there's no CH3 in here anyway. So let's carry on. What else can we cancel out? Well, we now have to, because we've got the methyl and a terminal alkene, we have to accept both of these. So let's look at the mass spectrum. The base peak is at 57, which is like a 4 carbon fragment, or it could be a 3 carbons with an O and a double bond in there some way. So we could have a peak of this sort in number 1, which we've already discarded, as well as number 6. We can't have 4 carbons with an oxygen and a double bond in number 4, so we can discard that one. So we've got the fragment there for that peak, and we can see this fragment over here at 29 is an ethyl, which this one does not have. There's no ethyl there, whereas this has an ethyl. So you can clearly spell out it can't be this one because it won't have that peak at 57, and it also can't be structure 4 because you can't form the peak at 29, but this one can. So you would say this would be the correct isomer. And that you can see is what it looks like if we compare the peak numbers. So this is number 1, that peak is number 2, the terminal, this one's number 3, bonded to the OH, and that's 4 and number 5. Kia ora.